Hello again. So we've heard a lot throughout the day about the need for a standardized way to measure the carbon impact of the components of a data center. We want to make sure that we can compare apples to apples as much as possible so that we can make informed decisions. When we're designing a data center, when we are looking at how those designs are going to evolve into the future, into a lower carbon iteration of what we're doing now, and importantly, when we're doing procurement. So we've talked a lot so far about the context of embodied carbon and how we tackle that very difficult problem. And I think that we've just witnessed and learned about a very important step forward in that area. And we have an opportunity now to also think about operational carbon and how we normalize that as well. And this is a good look into the kind of work that goes on in the sustainability community within OCP throughout the year. So this is the kinds of questions that we ask ourselves, the kinds of questions that we debate in our monthly calls. So we wanted to have this session as an open discussion, invite everyone in the audience to take part, to give feedback, and this is going to be part of our planning process for 2025. So we can start to think about, is this a project that we want to undertake? We could create a work stream around this based on the interest that we have from the community, and think about what we can do as a community to, again, take some steps forward here. So I will leave it to Shruti. My name is Alex Rakow, to introduce myself again, from Schneider Electric. I lead sustainability for the data center business at Schneider, and I will leave it to Shruti to introduce herself and to give some context for this topic.
Thank you, Alex. Yes, this is Shruti Sethi here again. I'm a senior PM from Microsoft, and we are also part of the OCP leadership, OCP sustainability leadership. And like Alex mentioned, this is part of brainstorming that we do in order to plan what are the work streams that we, in addition to the current ones, need to kick off, or what is that the industry wants or does not want. So feel free to raise your hand and ask questions in the middle, or actually we have a bunch of questions in the deck itself, so maybe you'll give the answers. So feel free to give answers in the middle. And from there, I think it'll help us figure out how much we want to go into this topic, or where should we target our efforts. I think this is just, yeah, okay. So the expected goal over here is to be able to establish a normalized carbon metric. Now the carbon estimation, for a minute, let's assume that the other work stream that is trying to standardize how carbon is estimated, that work stream is going to progress and have good results. Even with that, carbon raw numbers cannot actually be compared, just simply because different devices, different abilities of the devices basically make sure that it is a different carbon impact, so you can't just compare the carbon numbers. And that's where the thought of normalizing the carbon footprint comes in, so that we have a normalized metric that is comparable. Now, we did a little bit of a pre-survey, a very short pre-survey, before coming in over here. And as a follow-up to this session, we intend sending a broader survey to everybody so that we can collect data from that. And as a part of that pre-survey, we asked people about what do they think that normalized carbon metrics are going to help. Lucky for us, at least the main goal over here that folks pointed to aligns with what we were thinking, which is being able to compare the carbon for different devices and systems. We will talk about how it is different at device level and system level, and what different questions arise in both regards. The other question we asked people in the initial survey was, where do we see the biggest hurdle in this getting adopted as a metric? And not too surprisingly, the option that was most picked was that it's difficult to align on one particular metric. And I think that's the challenge for us going into this. We would need a lot of feedback from the industry over here, from expertise over here, in order to align onto one particular metric. Not only that, we also need to make sure that different industry forums that might be working on this, because what likely happens is many different industry forums work independently, and then we end up with 10 million metrics. Like we have a PUE, we have a CUE, we have an IUE, and you don't quite know which ones to focus on. So we are going to try to keep that in mind from the start itself. So this is a very high-level thought of the normalized carbon metric. So what we see over here is, if I need the normalized metric for a device, I am looking for the performance of the device, which has to be in appropriate attributes. I need the lifespan of the device, and I'm looking for the net carbon of the device. And net carbon meaning embodied and operational. What we want to get out of it is maybe something like net carbon per unit performance per unit lifespan or per duration. With this very broad thought in mind, again, we asked a few questions to our small polling group. And the first one of that was, where do we see the biggest hurdle in being able to measure or calculate this kind of a metric? The very first thing that came up is that if we need the performance of the device or the system, that is not expressed in a single attribute. So we are going to have multiple attributes that are required here. So are we going to normalize by multiple attributes? Are we going to pick a primary attribute to normalize? So all of these questions were basically raised. So this was the biggest hurdle that was pointed out. This second thing also pointed out from the survey, the questionnaire that we sent out, was a thought about, so if you see in our initial thought process, we basically just talk about net carbon being normalized, which basically means we are summing up embodied and operational carbon and normalizing it together. There was a different thought that came through the form of whether we need to have separate normalized metrics for the embodied carbon and the operational carbon. That might give you slightly better levers on both the sides. Maybe both of these need to be normalized by different attributes. So if I'm looking at operational carbon, which is coming from power usage, maybe I should normalize it by a different speed or throughput kind of metrics, while embodied carbon might be normalized by an absolutely different kind of ability metric. Again, something that we haven't closed on, but this was a thought process that was thrown out from the feedback form. The other important part that came from the very small survey was, of course, in order to normalize, we need the attributes of the device or the system. And those are going to differ according to the type of the device. So our first task here is actually to be able to categorize the devices so that we are building one normalized metric in each category, right? We could categorize simply based on what each device functionality is, or we could go a little bit broader. I'll give an example. We don't know yet, should HDDs be a category of its own and SSDs be a category of their own? Or should all storage devices be one category? So there are multiple questions around this fact. I'll let Alex take over from here, and he'll delve a little bit more into the feedback we got about categorization, and then some of the suggested metrics that came up in discussion.
So categorization is an interesting question, because when we're thinking about normalizing a carbon metric, we need to think about what we're normalizing it on. What is in the denominator of the metric? And it has to be a unit of performance. And so obviously there's going to be units of performance that are not comparable between a processor and a storage device, for instance. And as Shruti just alluded to, maybe we get even more granular, and maybe the units of performance are not the same between different closely related pieces of equipment. But if you're looking at work performed, how do we measure work performed of a storage device? Is it actually storage capacity? These are the kinds of questions that were bouncing around in our discussions and in our brains that led us to raise this work stream in the first place, or potential work stream. So the next question on the survey was, since different device types have different performance units, as I was just saying, we should have distinct normalized carbon metrics for which of the following? And you can see that the majority of the response we got was around storage, memory, processors. But really, I think if we're thinking about the value of a normalized carbon metric, we need to think about how we do it across all of these categories. How do we define a unit of work performed or a unit of value for that device that we can then use to make those informed decisions that I was alluding to at the beginning? And just to take a quick step back here, we've been talking a lot about comparing embodied carbon figures between different vendors or closely related devices, but those are static numbers and are not normalized by what unit of work that device is performing. So if you're comparing one UPS from Schneider to one from Vertiv, and we can compare those embodied carbon numbers, that's fantastic. We've achieved a lot there, but we still need to think about, okay, how do we normalize that based on work performed? Anything to add on this slide, Shruti?
Not in particular, but one thing that sort of did stand out from here was the feedback that GPUs be considered a different category as from processors. Maybe with the current ongoing wave, but also because maybe some things are thought in terms of number of cores and some are thought in number of flops. So yeah, that was one, I'll say, standout thing for me from this question.
Yeah, and you raise another sort of thorny question. Is it number of cores that we're normalizing on, or is it calculations performed? These are questions that are open.
So we did a very preliminary, based on the device categorization discussion from the early survey, we did a very preliminary categorization over here, picked the main few, which is processors, GPUs, storage, memory, and the networking devices. Now, like we were talking about, the performance in all of these might be expressed in different kind of attributes. So listed here are examples of a primary and secondary attribute that might be indicating the ability of all of these devices. So for example, for a processor, we are looking at number of cores, but then we are also looking at the TDP, or the power rating for these processors. That as a collective actually indicates how able the processor is for us. So based on that, we then started suggesting exactly what we were previously hinting, whether we need to normalize based on the primary, or based on secondary, or based on both. And I think this is what we were initially coming up with.
So based on the feedback that we got, you can see by category there some potential suggestions for how we could normalize in each category. Starting with processing devices, carbon per core, as we just discussed, storage devices, carbon per amount of storage, terabyte, memory devices, same thing. Networking devices, we're thinking about GBPS, what is the throughput there? GPU, maybe carbon per flops. So you can see for each that it's going to take some consideration to think about what is the most relevant unit of value. So I want to stop saying work performed, because it's not work performed for each of these devices, but how do we normalize based on the value of the device to the data center designer and operator, and therefore how can we normalize that carbon value?
On the previous set of examples, actually, there was also a feedback of maybe this is an incomplete amount of information, resulting from the fact that we have completely ignored a secondary attribute, or maybe some of these also have a tertiary or multiple attributes of performance, and only concentrated on using the primary attribute. Now keep in mind, this is going to apply to embodied carbon also. If it was only operational carbon, my natural thought process would say, oh, what are we doing for power right now? Like, do we say this much power per unit, say per unit TB? Then we think of it in the same terms for the operational carbon. But since this is now going to be applied to embodied carbon also, So we are still debating what are the attributes that can apply. So with the primary attributes alone, the feedback was that this is an incomplete information conveyed. When we introduce the secondary attributes, you see we have some of the examples that we were working with, where the normalization becomes with respect to cores and power, or for storage devices, it's terabytes as well as the throughput provided, so terabytes and Mbps. But I'm pretty sure some of you are uncomfortable even looking at these attributes, these metrics. And that was the kind of feedback even we immediately got, that is this now unintelligible? Like, is it conveying garbage? Because we have mixed together attributes that don't really sit together over here. So we are actually quite a bit between this one major question right now in order to normalize the carbon metric. I don't know if folks over here, if somebody already has an experience from metrics that are used within your organization or within your company, where you are looking at some kind of a normalization. We would love to hear if somebody can at the end raise their hand and share with us. But this is one major question where I think our discussion was continuously going back and forth.
Yeah, so as Shruti just mentioned, if we're thinking about how to normalize operational carbon, the first place that one would start would be, how are we normalizing energy efficiency for this device? What is in the denominator for energy efficiency? But we also have an opportunity to interrogate that and think about where our energy efficiency metrics for a particular device may be falling short based on those secondary attributes that Shruti raised. Yeah, this is a thorny one. So should the metric convey lifespan? If we're thinking about operational carbon, then it doesn't have a time vector because one device will be replaced by another. We're talking about how much energy it consumes per unit of value, unit of work performed. The lifespan becomes relevant when we're talking about embodied carbon as part of the same calculation or part of the same formula, because there we have embodied carbon over what period, and the longer the lifespan of that device, the lower the carbon intensity over the lifespan is. So that's where we would end up with carbon over performance over lifespan as the way to normalize if you were to include both embodied and operational. Anything to add to that? Yeah. So the feedback that we got from survey is overwhelmingly to include use life, which sort of by proxy means that we're including embodied carbon in this calculation, in the formula. And I think that that's probably what will be most meaningful in terms of a contribution to this whole discussion, is if we can not just focus on, okay, how do we go from energy efficiency to operational carbon, which hopefully isn't a very big leap, but how do you go from energy efficiency to life cycle carbon in a normalized way per device based on unit of value?
Oh, there's one more, sorry. Yeah, so, and I think the last part, so where we have sort of reached is there are at least, so there is a primary set of attributes conveying the performance. There is at least a secondary attribute in most of the device categories, maybe more than that. So we have these two primary and secondary attributes going in. There is a desire for the lifespan to go into this. So the ideal normalized carbon metric that we want should not only have the carbon, it should be able to convey the primary, secondary attributes of performance and the lifespan going in. Like, that's quite a mix. And I think we are right now sort of struggling with that mix, and which is why if anybody is actually already using normalized, we would love to have an idea of what they are doing. The last question that was actually raised was, we started this discussion completely on the device level, looking at how do you normalize for the device level. But the question that was raised was, how does this work for a server or system level? There we probably have an exponentially increasing number of metrics that convey the performance. And there was some thought process, not on the slides here, but some thought process that was expressed here, For example, if I took a server, maybe I want to look at the amount of work done by the server. So don't look at the number of cores in the processor in the server. Don't look at the capacity in the server. Don't look at any of these tangible attributes, but actually look at the amount of work done by the server. And now it will be a completely different way of normalizing carbon. It will be by the amount of work done. So that was one thought expressed for going higher than device level. We do think we are probably going to take some time work on the device level, and then we have some time to get to a server and system level. But I think that was the last discussion that we had based on the normalizing of metrics.
Yeah, it's important to note that we are contemplating IT devices here. I think I mentioned UPS before because I generally have Schneider on the brain, but we're talking about IT devices. And so the system level for what we're talking about, the system is the server. And it could simplify in a way what we're doing if we look at work performed by the server rather than each individual component. Yeah, so the call to action here is one that you'll be familiar with from the rest of the day and the whole track. This whole presentation, as you've seen, is the raising of a lot of questions. These are the kinds of questions that we contemplate and debate in a friendly way in the context of the OCP sustainability community. So we invite you to take part, go to the OCP website and click sustainability, join our monthly meetings, get in on the fun, and we can take this wherever this community wants to take it in terms of directions for the coming year.
One thing to add, we would send a broader survey out on this topic. I would request everybody to maybe take some time. It's likely going to be a couple of questions, so it's not like a 2-minute, 2-question kind of survey. But I would request if folks can take a little bit of time and maybe answer that. That would really help us. And with that, any answers?
Hi, I'm Savita, and one of the things I've worked on is a standard that is proposed by a Green Software Foundation, and they work on a metric for normalized metric for carbon, but more towards calculation of carbon emissions of software. So it's now an ISO standard, and it incorporates a lot of these aspects with lifespan and number of cores and things like that. So it'll be great if you can look at the software intensity of carbon, the SEI metric that is being used in the software industry. It has all the aspects of this. It's not device level, but more software focused, but it'll give you some idea on how it can be done.
So just quick question on that. So is that allocating a certain number of cores for some amount of software work? Is
Correct,
that how they are?
correct. There's resource sharing, there's time sharing, all those aspects that's being considered when you calculate how much of the server is actually being used for a particular application and things like that.
So this is very valuable, and I do find that the first thing we hear when we raise a new question in the context of OCP sustainability is, hey, there's another organization that's working on an aspect of this. And so a lot of what we end up doing is coordinating, learning from what others are already doing, figuring out, is there a gap that we can fill? Or is it a situation where kind of the work is already done and we can help to formalize and publicize? So I appreciate very much you raising it. Teresa, yes.
Hi, yeah, Teresa Nick, Microsoft. I really wanted to follow up on that server or kind of a higher level comment, because one thing that wasn't mentioned is the context. Like, I'm thinking of high-speed memory. If you have a system that's where you have a system where the GPU or the CPU is slower and can't, use that high-speed memory, then it's kind of wasted. And so kind of seeing this in the context, I think, is very important. And I would say, if I'm thinking about established methods, I mean, comparative life cycle assessment could allow you to compare like a server with 2 different types of memory or 2 different SSDs or whatever. But yeah, great work, thank you.
So, and also if I'm gathering one thought process correctly from your comment, is that when we are trying to normalize for a server or higher level, it's important to take into context how much of that ability is actually going to be used, right? Because there could be a max ability that the server is can withstand, but that's maybe not the amount of performance or the workload that's actually going to be used on that.
Right, yeah, just kind of putting it into the context of where you're going to be using it.
Right.
So with comparative LCA, and I guess the problem with that is if you're just trying to provide something to a community like you are, it's more difficult to do that. And so maybe it's an argument for kind of standardized designs where this is a 1.2 on this particular baseline, of carbon impact or whatever.
Yeah, you raised an important challenge. So looking at the server as the system helps us to put the individual devices in the context, see how they're being utilized. In terms of comparative LCA, when I think about the LCAs that we generate in Schneider, obviously this is not IT, but it's a standard answer, no matter who the customer is or how they're using the equipment. And so it could be that we look at the Microsoft design context here and try to normalize within that so that we make sure that we're being specific to the use case. But it's an important challenge.
Yeah.
Yes.
Two potential points of guidance, not much feedback for you, sorry, but I've come across in the LEED program from US Green Building Council, they have a LEED for data centers rating tool, and as part of that there's some credits achievable for IT equipment efficiency, and so they've tried to define their own metric similar to what you've been trying to do here. It's to do with number of cores versus megawatt hours input sort of thing. So there might be some existing reference point there for you to have a look at. Second point was going to be in the operational phase of, say, server equipment. I think it would be quite challenging to encapsulate that into a metric, because it will be variable depending on the workload, right? The server could be idle and consuming 100 watts, or it could be running a training workload and consuming 700 watts, right? And to make an assumption around, what percentage of its time is it doing nothing versus working at full capacity, that's a pretty, feels like it might be like a finger in the air assumption as to whether that's real or not. Yeah.
So on your first point, I'll resist putting Miranda on the spot as our USGBC expert, but there's a lot to learn from LEED in terms of standardization, and I think it's a good point of reference for us. And as to your second point, I think this is an important consideration for us, and that's what sort of led us to think about carbon per unit of work performed or unit of value. And there, so you're sort of obviating, is the server idle or being utilized, because you're thinking about it per unit performed. Now, if you're looking at the lifespan as well, then that's complicated by how often, what percentage of that life is the server being used. So it's an important consideration.
Yeah, I think this also aligns with what Teresa was also pointing to. So maybe there is a need for something like at a particular load, meaning when so-and-so measurement is made for the metric, there is a need to specify it's at particular load, or so much percentage of the lifespan is at this load. Maybe there is something of that sort.
Sure, and look, similar to when you buy a car, it'll give you some sort of fuel efficiency rating, and that'll be based on a typical usage cycle of how much time is on the highway, how much time is in urban areas, etc. So you might have to come up with some kind of assumption. Yeah.
Or we'd say this is the MPG highway and MPG within the town. Andrea.
Just one, so you talked earlier about separating out operational and embodied carbon. It seems like for operational carbon, that's going to be so dependent on the user's energy source emissions factor, where embodied carbon is going to be pretty constant, fairly generally, depending on the supplier. But also separating those out, it's nice to have them kind of in a one, so you can kind of figure out the whole life cycle carbon of it, but also separating them out can help maybe aid in decision factors. If you're valuing, if your operational carbon, you already know it's going to be low, you can value the embodied carbon impact at a much higher percentage.
Yeah, really good point. We've been discussing this as a metric, but it probably will need to be a formula, and one of the variables in that formula is emissions factor, because we just cannot prescribe that for operations. And don't know, Shruti, if you have an idea on that.
No, more of a, not an idea for sure, more of a question on that, or a question that was raised was, we were initially thinking of it as combined, and then, like you said, we were also thinking of it as separated out and normalized, operational and embodied separate. There was the question raised that if we do the separated out version, how do we exactly compare two devices of the same category? So similar devices, but still how do we compare those if one is better in the operational normalized carbon and the other is better in the embodied normalized carbon? Because now they might be normalized by different attributes. So there was also some questions thrown out around that part.
Yeah, thank you, Ari with Seagate. To simplify this, and I know my voice has been here before, but this came to mind here, is incredibly complex what we're trying to do here. I think the only way we can move forward is to have a model or three. Maybe hot data center, a warm data center, a cool data center. And speaking to storage from Seagate, it's like typically we have a 90 to 10 mix in exabytes of SSDs to HDDs, for example. That might be different in a hot environment, it might be different in a cool environment. But why compete between the two? Really it's a false equivalency. We really need the model itself to move down, not to compete against each other. So we might want to think about simplifying this around maybe as simple as three different data center sets. I do realize that's a lot of proprietary information, but maybe we can come up with that
I think it's
across OCP.
It's a useful suggestion. And thank you, Ari, for coming with an answer rather than a question. And I think it gets to the idea of, can we do miles per gallon highway, miles per gallon city, and then a third scenario that doesn't exist for cars. Thank you all for making this a discussion. We appreciate the questions.
Yes, that was really nice feedback that we are already getting.
Yeah.
And you'll receive the survey. We would also encourage you, like as this work stream is starting up, when you go, why is it not showing up? I guess my laptop went to sleep. But once you go to the Sustainability Project OCP page, you can actually join our work streams also. So if this discussion was meaningful, or you feel like contributing to it, please join us in the work stream also, so we can have this more refined and get to some kind of an output. Yeah. Okay. Thank you so much, folks.